Hello students, this is Mrs. Youd and today I'm going to teach you Chapter 2, Lesson 6 for my Algebra 1 class, Solving Absolute Value Inequalities. Today we're going to start in your journal on page 55. An absolute value inequality is an inequality that contains an absolute value. An absolute deviation is usually used in word problems. For example, if I were to say that the average middle school student age is 1 away from 12, then I would, on a number line, say that it is between 11 and 13, and I'm going to include 11 and 13. So notice that that is 1 away from 12 this way and 1 away from 12 this way. So what we would do then is our equation would be the absolute value of the age minus 12 would be less than or equal to how far away it is from 12. So that would be 1. So in this case, the absolute deviation is 1, and 12 is the given value. Notice that it's not negative 12 because that's part of the equation itself. So it's not negative 12. The given value is positive 12, but there is a negative inside this equation here. When you solve absolute value inequalities, if you're given this equation here, where x is greater than 0, what you do is you take you split it up into two parts, just like you did in chapter 1 when we dealt with absolute values. And it's going to be what's inside the absolute value is, notice I changed the less than to a greater than sign. So that's inside the absolute value is greater than the negative c, and what's inside the absolute value is less than the positive c. Another way to write this that's a little bit easier is whenever you have a less than symbol, it's going to be an and. So an easier way to do this would be negative c is less than ax plus b, which is less than positive c. And if you look at it, this piece right here is the same as this piece here, and this piece here is the same as this piece here. It's just easier to write it as one whole piece, and we'll be practicing this today. If you have a greater than symbol instead, you're also going to be splitting it up into two parts, but this time it becomes an or. And so when you split it up into two parts, what's inside the absolute value, flip the sign of the negative, just like what we did up here. Or this time, what's inside the absolute value is going to be greater than the positive. Okay, now we're moving on to page 56. So I'm going to put which one is which. So the less than is, remember, the and the greater than is, remember, the or from the previous page. So if we take a look at number 1, this is an and. So we could split it up into two parts. We could write y plus 2, and we're going to flip the sign. So flip the sign of the negative, and what's inside the absolute value, and then it keeps the same. Remember, a different way to do that I showed you whenever you have an and is you can instead write it as what the negative number 8 is less than what's inside the absolute value is less than the positive number 8. Most students prefer this way, but sometimes this way is necessary for some of the problems. So I'm going to go ahead and solve these. And when I do, I get y is greater than negative 10 and y is less than 6. Or if I did it over here, y is in between negative 10 and positive 6. Okay, so now let's graph. I had to count by 2's because of my space. It didn't allow me to count by 1's on this. So we're going in between negative 10 and 6. So I'm going to put open circles on 10 and 6, and it's everything in between those two. All right, this time we have a greater than symbol. So if I look up here, I see that a greater than symbol is going to be an or. So this time it's going to be an or. So when I split it up into two parts, it's going to be what's inside the absolute value is flip the sign of the negative, or what's inside the absolute value and then stays the same. And we're going to go ahead and solve both of these. And as an answer, I got q is less than -6 or q is greater than +6. So when I go to graph, I'm going to put open circles on both of those. This time it's an or, and so it's going to go from those numbers and out. So let's take a look at number 3. This time we have a very long inequality, and it's not simplified first. So if you remember back in chapter 1, when we had this kind of situation and we had an absolute value that had other numbers with it, we had to first solve for the absolute value. So that's going to be our first step here. We have to do that before we split it up, okay? So I'm going to subtract 10 on both sides of the inequality, and I'll get 3 absolute value of 2a plus 5, and then less than or equal to 27. Now I still have to get rid of that 3. That 3 is being multiplied by the absolute value, so I'm going to divide it out, and I will get absolute value of 2a plus 5 is less than or equal to 9. All right, so now let's take a look and see what kind of inequality we have. We have a less than. So if you remember, the less than means that it's going to be an and. And so the easiest way to do the and ones is to write it this way. We're going to do our negative number less than or equal to what's inside the absolute value less than or equal to the positive number. And we'll go ahead and solve from there. I'm going to first subtract 5, and that will give me -14 less than or equal to 2a less than or equal to 4. Now I need to divide by 2, and that will give me -7 less than or equal to a less than or equal to 2. And now we're ready to graph this problem. This time we have closed circles on -7 and +2, and it's an and, so it's everything in between. And so we go ahead and draw that. I would like you to go ahead and do number 4 and 5 on your own. So pause the video and then unpause the video when you're finished and see how you did. For number 4, I got -1 less than or equal to y less than or equal to 7. So they were closed circles between -1 and 7 and in between. For number 5, -7 is less than r is less than 1. Open circles this time and everything in between. Okay, we're moving on to page 57. Number 6 has the absolute value of something greater than a negative number. So let's just think about this for a minute. The absolute value of something, because it's a distance, it's always going to be positive. And then here we have a negative number. So what this is saying is the distance which is positive is greater than a negative number. And this is always going to be the case. This is always going to be true. So I'm going to expect that this is going to be an all real numbers or infinite solutions answer. I'm going to go ahead and solve it like we normally would. I'm going to use what we learned before. This is an or, which means that we're going to be doing what's inside the absolute value, f plus 12, is less than the opposite of what this is here. So the opposite would be a +4, and then we use the word or, and then what it's inside the absolute value is greater than what the number that we're given. Okay, so if we solve both of these, we're going to subtract 12, and we get f is less than -8, or, and then we subtract 12, and we get f is greater than -16. So let's just think about that on a number line. So if I graph this one first, I'm going to do this one in green. F is less than -8. So we have -8 as an open circle and heading down. And then in red, I'm going to do the other one. F is greater than -16. So I have this one coming up. So normally we would think if this was an and, it would be everything in between, but be careful, it's an or. So that means that this is true or this is true. And since we have something here going down, that means all of the numbers to the left of -8 is an answer. But also all of the numbers to the right of -16 is correct. And it's an or, so that means that it is all real numbers, which makes sense when we thought about it using this method here. I'm going to teach you a shortcut for saying all real numbers. If you just want to write ARN, that is a shortcut that a lot of mathematicians use for all real numbers. Okay, let's take a look at number 7. Here we have an absolute value, and again, just like up above, it's a distance, and so it's always going to be positive. And then we have a negative number here. So this is saying that a positive number is less than this time a negative number. Well, that should set off warning bells in your head. It is definitely not true. So I would guess that this is going to be a no solution answer. Let's go ahead and solve it though, just like what we learned. So I'm going to take the opposite of this number here. So it'll be +2 is less than what's inside the absolute value is less than the number that we're given, which is -2. And we're going to solve from there. So I end up getting 36 is less than x is less than 20. All right, so if I were to graph this, let's first graph this first part. 36 is less than x. So that would be an open circle at 36 heading up. Now I'm going to graph the other one, which is x is less than 20. So that would be an open circle at 20 and heading down. So notice that the graph is showing me an or, however, this is an and. And it is impossible to be both less than 20 and at the same time be greater than 36. So just like we thought over here, a positive number cannot be less than a negative number. So we thought, well, wait a second, that's a no solution. But we can see that when we actually do the problem, we can see that it is a no solution answer. I would like for you to try number 8 on your own, just number 8. So on number 8, it's a greater than, so that ended up being an or question. And when you solved it, you should have gotten x is less than or equal to -1/2, close circle at -1/2. I need to make that a negative here. Close circle at -1/2 and heading down. Or x is greater than +4, close circle at +4, heading up. Number 9, we see that the absolute value is not by itself, so we need to solve for the absolute value first. And when I do that, I get the absolute value of 3 minus k is greater than 0. So it's a greater than, so that means it's an or question. So when we split it, we're going to get that what's inside the absolute value is less than the negative 0. So there is no such thing as -0. 0 is neither positive nor negative. So it stays as 0. And then we say or 3 minus k is greater than the positive 0, which again, it doesn't make sense to say that. Okay, so now we're ready to solve for this. I'm going to subtract 3 all the way across. And now we need to divide out our negative. Be careful here, we're dividing out a negative and we have an inequality, which means that this one flips the sign and becomes a positive. So it's k is greater than +3 or, and then this other one is k, and I need to flip my sign, less than +3. So here is our answer, and now let's graph it. So this first one here, k is greater than +3. So I'm going to have an open circle and heading up. The other one, k is less than +3. So I use the same circle and it's going down. So basically the answer is all the numbers except for the number 3. Okay, let's read number 10. At a certain company, the average starting salary S for a new worker is $25,000. The actual salary has an absolute deviation of at most 1,800. Write and solve an inequality to find the range of the starting salaries. Whenever I'm doing these kind of problems, I like to work backwards. And what I mean from that is I like to look and think about it on a number line first. So we see that the starting salary is 25,000. So I'm going to put that in the middle. And we're told that the absolute deviation is 1,800. So what that means is it's going to be 1,800 this way and 1,800 this way. So we're going to add 1,800 here and subtract 1,800 here. So we end up getting 25,000 minus 1,800 is going to be 23,200, and 25,000 plus 1,800 is 26,800. So 26,800. All right, so these are what I want my answers to be, right? So now we're ready to go ahead and write our equation. So the equation, it says to write an inequality. So our inequality is going to be the absolute value of the salary minus the starting, the one in the middle, the average. So that's going to be 25,000. And then we want to take a look back at our picture here. We know that the starting salary is between 23,200 and 26,800 and everything between. So that means that this is an and. Okay, and so that means it's going to be less than or equal to. And then the deviation, the part that deviates from that starting salary, from the average salary, is 1,800. So the 1,800 goes here. Okay, and then we already have the solve, so we know that it's between 23,200 and 26,800. So I'm going to write 23,200 is less than the salary, which is less than or equal to 26,800. So these are our two answers. That's the inequality and then the solve of the inequality. Okay, that's it. Thanks for watching.